Hello friends, let's look at a newly appeared problem, the sum of good numbers. In this video, we're going to solve this problem by linear scan. So let me write it like this. Maybe we can term it that as practice the use of a flag variable or Boolean variable, right? So this problem actually can be solved in a very compact code, but in order to demonstrate the logic, we are going to write with some redundancy, in the sense that we expand the code and explaining the logic. So here we are given a string of integers called nums and an integer key. So an element at the index I is considered good if it's strictly greater than the elements at the index I minus key and I plus key if those indices exist. So here, if neither of those indices exist, so nums is still considered good. So we want to return the sum of all the good elements in the array. So here I'm not going to go through the examples because it's so straightforward. And also, the length of the nums is also very small. In other words, this is indeed an easy problem. But now we want to demonstrate to you how to use the flag variable and how to make close connection with the requirement of the definition of goodness in the statement. So now let me first introduce this in. This is the length of this nums, and I'm going to introduce this result variable. So we are going to accumulate this result variable by its good numbers, right? So then we do a for loop for I in range m. So first we are going to introduce a flag called good. Good is true, right? So for example, if there's no previous element number at I minus k or no afterwards number at I plus k, this is automatically good. That's why we set it to be true initially. And then we can get the previous and after indices, that is I minus k and I plus k, right? So then we first check the previous one. If I minus k is greater than or equal to 0, right? In other words, inbound. So in this case, so if nums I minus k is greater than or equal to the nums I, in other words, nums I is impossible to be strictly larger than this number. So we're going to set the good to be false, right? So this is the one. Do we need to check the second index? It depends on the state of good. If good is already false, we don't need to check. Therefore, we do this. If good, right? If good is still true, then we're going to check. Then we're going to see if I plus k is less than n. In other words, inbound. And if nums I plus k is greater than or equal to nums I, right? So then what we are going to do? So we're going to set good to be false, right? So after this if and this optional if good is still true, so we actually encoded this definition of goodness to these two blocks of code, right? So now we are going to accumulate this result variable. So if still good, then we're going to do result increment by nums I. Then therefore, afterwards, we just need to return the result. So let me first run it. Yeah, it passes the two test cases. Now let's look at the generic case. Yeah, let's run it again. Yeah. So here, because this just do a linear scan, the time complexity will be O of n. So the space complexity, we just introduced this result variable n, and here good, previous afterwards. So the space will be O1, right? Let me write here, time is O of n, and the space is O of 1. So with that said, I guess that's it for the current easy problem. So here, as I mentioned, we just practice how to use this good flag variable and how to encode the definition of goodness into the coding. That's it. Thank